To get the most value out of SAP Analytics Cloud, the data you import must be well structured. By this we mean organised into rows and columns. Now for some SAP Analytics Cloud data sources, for example cloud-to-data feeds, it's almost impossible to check for data integrity until you attempt to import the data into your model. But given that I'll be demonstrating SAP Analytics Cloud using an Excel file, we can easily review this data first before attempting to import. I've attached the sample data sources as the supplementary materials of this lecture, so please make sure you've downloaded it to your PC or Mac. And I'd also recommend you take some time out to look at our Excel file, as it will help you understand the context of our demos. The primary frameworks of SAP Analytics Cloud are called data models. These models contain dimensions which are hierarchical structures where organizations can handle their accounts, business framework, or any other criteria they need to plan or evaluate results. There are two types of model in SAP Analytics Cloud, planning and analytics. The planning model can help us perform planning activities, while the second type, analytics model, is a review-only structure that allows users to evaluate the data gathered. We can import a file from computer or from a cloud app such as Google Drive or SuccessFactors, or connect with a data source such as BBC, SAP BW, SAP ERP or SAP HANA to build a data model, so there are multiple ways of creating data models in SAP Analytics Cloud. In this video I'll show you how to create an analytical model using an Excel file. The Excel file we'll use is the sales transaction data for some products. Now, here's the landing page of SAC, and we navigate to Home, Create, Model. Select Import a file from your computer. Click Select the file to import the data, and then click the source file sample data1.xlsx. We can mark the first row as column header by selecting the checkbox Use First Row as Column Headers, and I've already put a header name in the source file. If we have multiple data sources, we can create schedules to import data into models on a one-time or recurring basis, and in this course our model only contains one data source. When you click on Data Integration tab, you can see the data we just imported. Here we can find that SAC has defined the dimensions of the data automatically. To determine what content to include in your model, you must first identify the columns from the source data on which users need to query. Then, to establish the role played by each column, identify whether it's a dimension or a measure. The most fundamental dimension is account dimension. It defines the set of account members and the format of the account data. In SAC, when we create a data model, the basic columns like member ID, description and account type, and a set of technical properties will be automatically added into account dimension. There are many other dimension types in SAC. The most used one is generic. It's a free format dimension like product name, channel category, or sales representatives. Data represents the date and time of the data, and you can also have more than one date dimension in a model or story. The organization dimension is not mandatory in a model, but it gives us an organizational analysis of the account data. For example, an organization dimension could be based on operating units, geographic entities, or cost centers. Measure represents transactional data like sales and price, and of course if you think the automatic ones are not very accurate, you can change the setting here. Then we go to Details. This panel will display the overall information about our dataset. Let's go ahead and click on the drop-down menu under Type, and you'll notice that a few options appear here. The one we're going to change the dimension type from generic to date. And then we find the column Material doesn't represent a separate dimension. It represents an attribute of the Product ID column. To define the column as an attribute, select the Product ID column, and then in the Details panel, select Add Dimension and Attributes and Property, then select Raw Material. Let's select the Product ID column, select Add Dimension Attributes, then Parent-Child Hierarchy, and select Product Line. Hierarchies are useful when there's a hierarchical relationship between two columns such as category and product. Setting up the columns as a hierarchy allows us to drill up and down between the category and product values in charts. If hierarchical dimensions are included in a chart, you can drill up or down through dimensions to explore the data at different levels. In this demo, we'll use the parent-child hierarchy. This defines a hierarchy for any generic dimension. For example, if your imported data contains two columns, country and city, you can set the country column to be the parent of the country-city hierarchy. You'll see the product line column is now defined as the parent of the product ID dimension. And there you have it. In just a few steps, we've transformed our draft data and also updated some of the column attributes. In my project experience, there's nothing worse than creating charts that just don't look right or don't make any sense, and it's often because there are issues with the integrity of source data. So before we create our data model, we need to validate the data first, which takes a lot of time and effort in a real-life SAC implementation project. So please make sure your data model is all set before creating any further analysis and visualization.